Okay, today we're going to talk about section 1.4, and that's about functions and their graphs. And here are the objectives. You want to know what a relation is. You want to determine if a relation between two variables is a function. You want to understand that a function is a special kind of relation. You want to understand function notation. That's that f of x that you may have seen. You want to understand the concepts of domain and range and be able to find the domain of a function. We'll talk about range a little bit, and later on in another day, we'll get into it in more depth. And we want to use functions to model and solve real-life problems, i.e. word problems. And we will not cover difference equations, which is in the text, so you don't need to read that section of 1.4. Okay. So, a lot of things in everyday life involve a relationship between one thing or set and another thing. And that's a relation. And I want to give an example in real life that's based actually on that word relation. And this relation is the relation between you and your family members, and between you and your family members. And so the relation is going to be from this set over here. So from this set here, which we're going to call set A, to this set over here. Oops. And that's going to be set B. Okay. So let's look at this relation for a second. If I ask you, give me a relation, you could give me any number of answers. There's not one answer. There's a multitude of answers. So a relation does not have to have just one answer. A function does, but not a relation. So this is an example of a relation that's not a function, because you could name any relative. You could name your father, your mother, you could a long-lost relative that you just recently discovered, or a relative that died in the 19th century. Now, a function only has a single answer. So we'll see an example on the next slide. Okay. So, so think about this question. How old are you in years at exactly 12:01 this morning? There's only one answer to this question. The relation between you and a particular point in time and your age is a function. So yesterday, at that time, I was 66 and 341 days. Today, I'm 66 and 342 days, and tomorrow it'll be 343 days. So a function is a function of a variable, and we're going to use t here for the variable because that t is going to stand for time. And that's often the case. Like usually when you see t, the variable t is almost always, not all the time, but equal is supposed to invoke time. Okay, and so that's why we use this notation, f of t, f for function and t for time. So if f of t is my age at time t, and to is equal to yesterday, it's 66 and 341 days. Today I'm a day older, and then tomorrow I'll be a day older yet, and so it'll be 66 and 343 days. So here's a visual example of a function with a diagram. At a particular time of the day, what's the temperature? Notice it can't be two temperatures at once. So at 1, it's 9. At 2, it's 13 degrees centigrade, and that's just close to 60 degrees, a little bit less. At 3, it's 15 degrees centigrade. At 4, it's 15 degrees centigrade. Temperature didn't change. At 5, it's gone down to 12, and at 6, at 10. So notice that each value over here in the blue only has one over here. If 4 also went to 13, that wouldn't be a function, but that's impossible. It can't be both 13 degrees and 15 degrees at 4 p.m. in the same place. So just so keep that in mind. So this is a function, and the fact that both 3 and 4 equal 15 is fine. There's no problem because 3 has only one y value, and 4 has only one y value. And just that, I'm thinking of these as my x's or t's, I guess, right? Let's make this a t for time. And the other one is x's. Okay. So here's a more mathy example. It's the square root of a number, a function, and is the square of a number a function. Think about it and go to the next slide. I'm going to go there right now, of course, but you're going to pause and come back and join me. Okay. So is the square root of a number a function? No, because we could have two numbers. Think of 16. If I say what's the square root, it could be 4, it could be minus 4. How about if it's the positive square root of a function? Yes, that's a function, okay? Because there's only one positive square root. square roots are either negative or positive, so there's one positive. The positive square root of 14 is, I'm sorry, of 6 is 4. How about the square of a function? Yeah, a number is equal to 4 times itself, and that can only have one answer. So squares are also functions. This is a typo, so we're just going to cross that out. Sorry about that. Okay. So there's a tip on parentheses. Be careful with them. You do, the parentheses, it's minus 4 times minus 4. That's 16 because that means there's, two negatives. Negative times negative is positive. But this is actually going to be minus 16. And here's how you interpret this. First you square, and then you multiply by minus 1. And why do you do that? Well, it's the order of operations. Please excuse my dear Aunt Sally, or PEDMAS. And that means you do parentheses first, then exponents, then multiplication, and so forth. So I look at this here, and there's no parentheses, so I don't worry about that. And I look for exponents. Yep, so first thing I do is 4 squared, and then I multiply that. That's the next thing I do, and that multiply is the negative sign. And 4 squared is 16. So what happens here, this becomes minus 1 times 16. And that's equal to minus 16. So again, just a tip, keep that stuff in mind. And from time to time, I am going to do that. I'll show you some sort of technicality about the math that I think will be helpful. Okay. So here's a formal definition of a function. A function goes from a set A, so that would be A, to a set B, that would be this one over here. So it takes a value of x, so I'm just singling out one value, here's x equal 2, and that goes to 13. So that means that would be over here, this would be my y value associated with 2. So that would be, if I had a function, that would be f of 2, and so forth. So a function is a function f from a set A to B is a relation that assigns to each x over here exactly one y over here. And this arrow tells you which y is connected with which x. So 9 is connected with 1, and so forth. So the domain is the set of inputs. So if you look here, the domain is going to be 1, 2, 3, 4, 5. So that's going to be this right here. Now the range, let's see, 9 is in the range, so we put it in there. 10. 11 is not in the range, so that doesn't get put in because there's no arrow to 11. 12, yep, that's in the range. 13 is not 14, that's over here. 15 is, and that's it. There's nothing else. So the domain has 6 values, and the range has 5. That's because there's 15 happens twice. Okay, so some technical stuff about square roots. When you see x, it means the positive square root. If there's no symbol, and if you just see the minus, it means the negative. So that whenever you see this, we know we mean positive. So 16 square root is 4. Remember, it's really the positive square root of 16, which is 4. And the negative square root of 16 is 4. However, when you take a square root of the number in a problem, you need to do both. So we're going to have an example soon where you have to solve that. And to solve that, remember, you have to find all the answers. So I start here. X squared is 16. And so I want to figure out what x is. So I take the square root here. But I have to do the plus or minus square root because I need to account for everything. So I take the plus or minus square root of 16 plus or minus 4. And so notice my solutions, and I want all solutions when you solve a problem, is equal to 4 and minus 4. I wrote it backwards, minus 4 and 4. Okay, so again, just keep that in mind. So when you see something like square root of x minus 6, also keep in mind you can only plug in numbers where x minus 6 is not negative. So remember, we can't take a square root of a negative number. So we can't take a square root of a negative number. So square root of a negative number. So an example would be this. That has no sense. It doesn't mean anything. And why can't a square root be negative? Well, we're only dealing with real numbers. And if the square root were negative, then we multiply negative times negative, we get a positive. So we wouldn't have the square root of negative 6. And if the square root of negative 6 is positive, then we'd multiply those two numbers, and we'd still have a positive number, not 6. Okay. So what you do here, when you need to figure out, when you do the domain, if that's your function, you want to find the domain, here's what you would do. You'd find out what x's you can plug in. You need to solve this, because that's the same as, this means it can't be negative. Right? It's 0 or above. So that means it can't be negative. So I solve this, and to solve this, I'm going to add 6 to each side. I add 6 minus 6, I get just plain old x. 6 to 0, I get 6. So that's my answer. X is greater than or equal to 6. So that means that only values 6 and above can be plugged into that expression. So the first rule of Math 20 is that you can't take the square root of a negative number. Okay. So this is kind of a review here a little bit, and also just to sort of summarize things. We've already talked about the definition of a function, and mathematicians like this will cover any function that has to be this. A function goes from a set A to B. So one way to visualize that is that f takes a number from A to B, and then it assigns an element in x to exactly one element in y. In other words, it can't have two answers, only one answer. And the function's represented by this notation, and x is any domain member. And y is what you get when you plug in x, and that's in the domain. A domain of a problem can be given in two ways. It can be specified. In other words, the problem states the exact domain, or inferred. The problem doesn't state the domain, but you have to say, oh, okay, any number for which the formula makes sense is possible. And remember, things that make sense are you can't have a negative square root, and you can't divide by 0. That's the second rule of Math Club. The first rule of Math 20 Club is you can't take the square root of a negative number, and the second rule is that you can't divide by 0. So, okay, so here's our example. We have x minus 6, and the domain is specified here. These are the only possible values right here, 6, 10, and 15. So if you want to find out what happens, we plug in 6. X is equal to 6, we get y is equal to 0. Okay. If x is equal to 10, plug it in, you get y is equal to 2. And over here, if we plug in 15, we're going to get y is equal to 3. So that tells us, that tells us that y is 3. So y is 3, y is 2, y is 0 are the only possible y values. So up here we have the range because it's specified as 0, 2, 3. I'm sorry, the domain is specified as 6, 10, 15. So our range is only 0, 2, 3. That's because of these numbers. So the second answer, we just give this, and there's no restriction stated, so the domain is inferred. What you do there is the domain is everything for which this is valid. Now we saw on the last page that this is only valid if what's inside is 0 or above. That means x has to be greater than or equal to 6. So the domain is x greater than or equal to 6. And we can also write the domain this way if we wanted. We could write it as 6 with a bracket and infinity. And 6 means that 6 is included. That's what that bracket means. 6 is included. And then we have a parenthesis here because infinity is not a number. Okay. So here we figured out that the domain is this right here, and then the range is going to also be all real numbers greater than or equal to 0. And the reason that is because a square roots are either 0 or positive, because we didn't specify here. So that means it's the positive square root. So square root can be 0 or positive. So that's our range right here. Okay. So another summary is how do you describe a function? You can do verbally. And this verbal, what I include here, this also means a picture. So visually, by a sentence or a diagram, like we saw before, where we had temperature. So that's one way to do it. So example, the square of a number, or what was the temperature, that example. Now numerically, it's a list of ordered values. So this is our function here. So here, they're stating the domain. So D is going to be all the numbers from whole numbers from -2 to 2. So -2, -0, I'm sorry, -1, 1, 2. And then our range is going to be the possible y values. Usually start from lower and go to higher. So y is 1, y is 4, y is 7, y is 10, and y is 13. So that's going to be the range. Okay, graphically, you give a graph here. And we're going to assume that this graph goes on forever. So here the domain is going to be equal to all real numbers. And that's going to be the same with the range. The range is also, because the line just keeps going up, goes to infinity, goes down to negative infinity. So the range is going to be all real numbers. Now we have a special symbol for this. You may have seen it. And that's going to be here. That symbol is going to be, it's an R. It has like 2 lines instead of 1. So it looks like that. And then here again, that stands for all real numbers, that symbol. Okay. Okay. Or finally, if you want, you can give an algebraic example like we did here. Okay. So here's an example. Is the following relation a function? And remember, a function can only have, for each value in a, there can only be one y. So that means each x can only have one y associated with you. So usually the input x's are a, which is the domain, and over here b is going to be the set or the range. Okay. Okay. So think about it and pause, answer it, then restart the video. Okay. The answer is no. If you notice here that this x is associated with 11, and here x is associated with 10. So in other words, since if I ask x equal 2 and you say what can be associated to it, there's 2 answers, it's not a function. X is matched with both y and 10, y 11, so it's not a function. Okay. So about function notation, we usually write f or g, and there's a lot of notation with that, and then sometimes we give a special name. And so usually what we have for a function is usually f is going to be equal to a formula. And again, the formula can be implicit. It may not be stated. So over here, there's not a formula for the sign. So we don't know what the formula for the sine and log is. We use like our calculator. Okay, so like right here, and here's an example of one that's specified with a formula. F of x is equal to 4, f of x is going to be equal to x squared minus 4x plus 7. So what that means is whatever you plug in here, imagine that it automatically completes these columns right here. So a 3 would go here and a 3 would go here. And then your answer would be, it would be equal to 3 squared minus 4 times 3 plus 7. That's going to be 9 minus 12 plus 7. 16 minus 12. So that's going to be 4. Okay. Now, this can be absurd. If I put dog here, let me do that. If I put dog here, imagine the 3's not there anymore, or here, then that means this gets filled with dog automatically, and that would mean that this would also get filled with dog. So it's really mindless. Whatever goes here, goes here. So again, and I'm being absurd, f of dog would be dog squared, 4 times dog, and 7. Again, just trying to sort of indicate that whatever, that functions are kind of mindless. And whatever you put in one place, you have to put it in the other. Okay, so is this a function? Why or why not? And what's the domain? And remember, a relation has a domain as well as a function. So go to the next page. Again, you work on this a bit. So it is a function. And why? Well, let's go to look at it. So if I look here, that if I plug in a number and square it, no matter what I plug in here, it's going to give me a number. I subtract 16, that's going to give me a number. I take its reciprocal. That's a number. It's only one number associated with it. So yeah, it's a function. Okay, that's what I'm trying to express here, that no matter, all these operations yield only, if you plug in an x, you only get one number. Okay. Now the domain, remember the second rule of Math 20 Club is that you can't divide by 0. So this means that the bottom can't be 0, so x squared minus 16 cannot be equal to 0. So we have to find out the numbers that make it 0 and exclude those. So what I'm going to do is I'm going to solve x squared minus 16 equals 0 to find those numbers. So to do that, I add 16 to both sides. And then I get this equation. And then I take the square root. And remember, I have to take both the positive and negative square root because I want both solutions. And so I get x is equal to minus 4. Now we have to exclude those, so the answer is all real numbers. The domain is all real numbers except x equal plus or minus 4. Okay. What's the domain of this function? Again, you want to keep in mind that we know it's a function because it only is going to give one answer. And keep in mind that 4 minus 3x can't be negative. So that's your key. So start working on the problem and then solve it or make as much progress as you're able and then then start up the video again. So, okay, I'll let you pause while I go to the next page. Okay, so you've rejoined me. So I need to say when this is greater than or equal to 0, right? It can't be negative. So I'm going to add 3x to both sides. Then that goes away, and I get 4 is equal to 3x. Now I want to solve for x, so I divide that by 3 and this by 3, and I get this. But usually you put x first, and so I'm going to write the answer this way. So in other words, x has to be less than 4/3. If we write this on a number line, this is 4/3. So anything over here has to be less than 4/3. So that's going to be the interval minus infinity to 4/3. And remember, when you have the bracket, means 4/3 is included. So this bracket means that 4/3 is included. Okay. Okay, here's the formula for the volume of the sphere. What is its domain? It's going to be a function. Think about it. Each time you put in a number for radius, you're going to get just one number. So it's a function. And remember, don't forget a radius can't be negative. And remember, anything that's physical, we think it can be 0 or nothing. If you have a really, you can have a circle of radius 0 is no circle, but you can't get negative. And then, so you can't be, we don't know what a circle of radius minus 3 would be. So keep that in mind. Okay. So again, you can plug in that has to be 0 or above. That means x is greater than 0, greater than or equal to 0. 0 is included. And so again, sorry, let me take that back. So we have this, and if we have the number line, that means 0 is included. Go all the way up to infinity, so that's 0. And we have a parenthesis here. That means infinity is not included. And that that means it's because they are, it's not a number. Okay, so we're going to go to the last problem, finally, and you work in a marketing department of a soft drink company, and you're experimenting for a new can for iced tea that's narrower and taller. You want the ratio of height to radius to be 4:1. That's what your marketing has told you. And this is the volume of the cylinder. So we got three questions. Assume you know the height h, write the volume of the can as a function of radius r. This means, sorry, let me do it this way, get rid of r. If you write it in terms of h, that means, I'm sorry, get rid of h. If you're going to use, if you write it as a function of r, you don't want any h's. Okay. So assume you know the radius r, write this as a function of the height h. So here, you would get rid of the h. I'm sorry, get rid of the r. Look what I write, not what I say. Get rid of r. Okay. So again, you'd want to try to write this, and just a little bit, this is key right here. The ratio of the height to radius is 4. That means that the height is equal to 4 times r. So if you want to do it as an equation, we have h is 4r, or if I divide each side by 4 to solve for r, so I want to get r alone, I divide by 4, then I get h over 4 is equal to r. Okay, so remember you need to get rid of h, so this tells us how to get rid of h, and this will tell you how to get rid of r. Okay, so I'll let you work on this for a bit, and then, let's look at the solution. Okay, so hit pause, and I'm going to go to the next slide. Okay, here we are. I just repeated the question, and we mentioned before that these are the key facts, that h is 4r, or r is going to be h over 4. Remember, this is going to be the same as h over 4. Sorry. Okay, so we write the volume v of r, meaning the volume is a function of r. We need to get rid of the h, so we're going to use this. And then whenever I see an h, I'm going to plug in 4r. So that's what I do here. Here's my h, plug it in here, 4r, and then I get volume r is going to be this. Notice that there's no h's left. That's going to be, give me 16. And r squared times r is r times r to the first, so r cubed. So that's what we get. That's my answer. Notice there's no h. So I do the same thing over here. And if you got it wrong, maybe try the second one. Pause it and try it. I'm just going to go right into it. For b, we want all h's, and that means we need to get rid of the r. So we're not going to have an r. And so that's what this tells us. This tells us how to get rid of r. So whenever I see an r, I'm going to, in that volume form, I'm going to put 1 over h into it. So, sorry, this should be an h here. We want v of h. Here, let me do this better. Let me do this. This is going to be v of h. And let me fix this over here. This should also be v of h. And we're getting rid of the r. This should be v of h. And finally, this is going to be v of h. So I'm sorry about all that. Okay. So we're going to find v of h. We know that this one, we're going to plug this into r. And so that's what I do here. Oops. And then that's going to give me v of h is going to be equal to 4 pi, that 1/16, I square 1/4, I square h, times h. That's going to be, oops. Sorry, that's going to be h to the 1. I can do better than that. And so when I multiply these together, I'm going to get h cubed. And so that's what I get over here. V of h is going to be equal to 4 times 16. So I multiply 4 times 1 over 16. I can factor out a 4 from here. And I get 4. That goes away. It cancels. And so I get 1/4. So my answer is going to be V of h. Let me write it down here. My answer is going to be V of h equals 1/4 pi h cubed. And that's my answer. Okay, and that's it for today. Thank you.